So I have one more example here. This is a for loop that prints the set of even numbers, but the range I'm using here is 100. So the set of even numbers starting from 0 to 100. How do I do that? I write a for loop having my initialization statement to be equal to 0. Then I check for every of my iterator I, which is less than 100. Then I increment the value of I by 1 for each of the iterator. So for this, the block of code to be executed is starting from here up to this point. So starting from here, it says if I, this is a modular operator, which means it will divide I, the value of I, by 2. Then the remainder is what you to be taken. It says if I divided by 2, let's say for instance, if I is 5, so 5 divided by 2 will be equal to let's say 2, yeah, 2 having a remainder of 1. So this is the result that will be gotten in this statement, saying if I is divided by 2, which will be returning the remainder. If the remainder of this operation is not equal to 0, then it should that uh, skip the execution of that that iterator. You should skip the execution of that code, which means a continuous statement. I have another control statement that I can use, which is a break statement, which will terminate the loop. But I'm going to get into that. But let's use this. It says for I is this, I is less than 100, and I should increment. So if the remainder, when my I is equal to any of these values, let's say I is equal to 5 according to what I have here, then dividing it by 2, the remainder, if the remainder, which is 1, if the remainder is not equal to 0, then keep it, don't execute anything, which means continue. So if you skip that, the only thing it will be printing is those ones that it do not skip, which is if the remainder is equal to 0. Let's say for instance something like this, let's say this one is equal to 4, or let's say yeah, 4, which will be having remainder to be 0. So if this remainder is equal to 0, that is if it is equal to 0, then nothing should happen, it should just print this. But this one is testing for if the remainder is not equal to 0, which means it is not an even number, then you should skip the execution of anything. It should just start from this for loop again. You should go to the top and start the execution of it. So for all those other ones that their remainder are equal to 0, this is the block of code that will be printed to the screen. So let us check this where we compile our program, which is go run loop.go. That's the name of the file, loop.go. So it prints out 0, 2, 4, 6, 8. So these are the set of even numbers up to 98. And how do I print it out? Using printf, that is formatted output, percentage %d, which is format specifier for digit. Then I put a space in between. Then what am I printing out? I'm printing out my iterator variable, which is I. So that is about this one. Okay, so that's for continuous statement. It exists this execution of this loop if by the time I divide this and it is not equal to 0, it exists the loop. So let me check for this. Let me check for another condition. If I is equal to 50, let me use I is equal to 50. If I is equal to 50, then what should happen? It should break, which means it should exist from the loop. It should exist it totally, not just to skip it and continue. It should exist the loop totally. So now let me recompile this and see what I have there. So go run loop.go. So by the time it comes to the turn of I, which is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, up to 49. By the time I is equal to 50, then it stops the execution of the code, which is break. It exists and terminates the for loop. So that is the use of a break statement in our code. I comment this out and let's check this next example here. So what I have here is A loop to print the factor of number up to 100. Factors of number up to 100. So this is where my code starts from, I think. So I uncomment this and I move to the top. Let's see what this does. I have my variable initialization, which is I and j. Declare a variable for the iteration. So what I'm having here is a nested for loop. For here, for loop here. So I first have my print statement here, which is set of prime numbers. Then print no, this is a set of factors of number. Factors of number. Factors of number, then print a new line. So for I is less than 100. Wow, this is another way I can declare a for statement by having only the condition to be checked, because I have my initialization variable. According to variable initialization, they go to their default value. For integer, their default value is 0, while for boolean the default value is false, and for float it is 0.0 and so on, whereas for string it is just an empty string. So that is the default value. So this one is set to the default value because it's having type of integer, but I is of type of integer, which means it is assigned to be 0. So if I is already equal to 0, I don't have to be repeating the same thing. I'll check for my condition. I is less than 100. So I is always less than 100. Then what should happen? You should execute this block of code. Then at the end of this all, you should increment my variable I before it prints a new line. So this is a determinating statement that I have here. We should be increasing the value from this iterator so that it will be able to terminate from infinite loop. So I have this here, which is print factors of this. Factor of a number is, then you should check for this. For j is equal to 2. I already have j here, so I initialize it to be 2 here, whereas I left I to be equal to 0, which is its default value. Then I check for j is less than I, which is 0, then j should increment. So if I divided by j is equal to 0, if I divided by j is equal to 0, then this is the block of code to be executed. fmt printf. So let us look at that. If the I variable divided by j is equal to 0, which means if, let's say for instance, my I is 5, then if j is set to starting from 2, so 5 divided by 2, if the remainder is 0, then it should print that thing out and say, okay, it should print out that number that it can divide, that number which is j can divide 5 without any remainder. So that is what this is just going to print out. It's just going to print out these digits at the front of this printf statement here without printing a new line. So at the end of each is when the new line will be printed. So now let's compile this program. I first clear my screen. So let's compile this program and see the output that we'll be having. Okay, sorry, I haven't saved my file. I come back here to save it. I clear my screen again and I re-execute my code to see my output. So the output I'm having now is oh wow, I have very long list. So I have to go up. I have to go up and check for each. It says factor of 0, factor of 0, factor of numbers. Now factor of 0 is nothing, factor of 1 is just 1, factor of 2 is 2. Okay, factor of 3, no, 1 and 3. So it check starting from 4, which is the first real number I can have. Factor of 4, that is number that can divide 4 excluding 1 without any remainder. I only have 2 and 4 itself, because what I used here is less than. If I should use less than or equal to, then it should probably print the other 4. So factors of 5, no number can divide 5 without remainder. Factors of 6, 2 and 3 can divide 6 without remainder. Factors of 7, no number can divide 7 without remainder, which means 7 is a prime number, 5 is a prime number, 11 is a prime number, and 13 is a